Ready, go.
Hello!
Hello, Mr. Eric, Mr. Ryan. Do you still remember what we talked about yesterday? Something about breakfast search, yeah?
Yeah.
And it's like the binary tree, and what we want to do here?
We gotta do
The maximum. We find the level which has the largest sum, right? In this case, look at the level 0 is 1, level 1 is 5, level 2 is 4. So we return level 1 because it has the largest sum 5, right? Remember, how are we doing it? How are we doing it?
using this Q.
Yeah, which is what search? Breakfast search, okay? So breakfast search, because we visit the rows, visit the binary tree level by level, and using a queue, which is first in what queue? What's queue?
First in, first out.
Yeah, in Python, what are we using? The
Stack.
Not the stack, queue. I just saw queue. What class name of the queue are we using in Python?
DQ?
DQ, yes, DQ. Double N DQ, yeah? So now, today we can use the DFS search. So what's DFS search? Can you tell me?
We're going as deep as we can.
Okay, so for example, if there are trees like that.
5.
So what's the DFS search?
6.
Okay,
1.
so. Yeah?
2.
Yeah? What? 1, 2, and then what?
Maybe 5.
Yeah, 5, and then what's next?
And maybe 6.
6,
and
yeah.
maybe 7. And maybe 3. And maybe 4.
4, yeah. It's not maybe, it's
Maybe or maybe not.
it's 1, 2, 5, 6, 7, 3, 4. And what's the breakfast search? What's the order of the breakfast search?
1, 2, 3, 5, 6, 4, 7.
Well done. Yes, well done, Ryan. You're listening, yeah?
1, 2, 3. Yeah.
Okay, so we can do the DFS search, but we also need to what? So we visit the node, and then we put the sum. We accumulate the sum of that level with the value of the current node. So in order to do this, we need to be passing the level in the DFS search, right? Yeah. Somehow, when we recursively visit the node, we need to remember which level it is. Right?
Yeah.
Yeah. Okay. So
So
define DFS search root. So we also need a level. Yeah. Level. And then we let's put it in a sums.
I thought they say let's use
Sums. So sums is a dictionary. Alright. Sums is a dictionary with the key. Alright. Key is the level. And then value is the sum for that level, right?
Oh yeah.
Okay, so look, if root is none, what should we return? What should we do? We just return, yeah? Because it's none and then we just return, yeah? Okay?
Yeah.
We can, look, we don't need to return anything because this is the function. We don't need to return anything. The purpose of this function is to accumulate, to update the level, to add the sum of add the node value of the root to the level, right? Alright? Alright.
Yeah.
So look, so how do we add the root of value to the level with the sum? So look, sums is a dictionary. What did I just say? The key is the level, okay? Alright? Alright, can you pay attention? Not just play around. Okay, sums. So what should I put here? The key, what's the key?
The key.
And then plus equal what? Plus equal what? Huh? What's the key here?
The key is level.
Level, well done. And then plus equal what? Plus equal what? Root of value, yeah?
Yeah, see, I'm playing attention.
Okay, now we're going to visit the left tree.
Oh yeah.
With the what? The DFS search. Visit the left tree recursively, alright?
Yeah.
So can you tell me what's DFS here? Passing what? Passing with which value?
Where?
What value? DFS. We want to visit the left tree. So what's this?
The left tree is root dot left.
Okay, and then what's the level value? What's the level value? We go down, and then what happened to the level value?
The level value.
What?
We start a new line.
Yeah, the level current is level, and then we go down one node. So what happened to the level? What happened?
Level.
Yeah. What? What? Here I'm add over.
1.
Yeah, and then sums. I passing the sums as well. Okay. And then what should I do? Visiting the right tree. Can you do this?
Read the right.
Yeah.
Level add 1 sums.
Yeah. Okay. Okay. So look, this is depth first search. It's simple. Yeah. That's it. So when I call this, I just need to call depth first search. Look, before that I need to create a. Look, this is the root, and the value I'm passing at the beginning is 0. Yeah. And the sums. Look, this is sums. Alright. This is the function.
Yeah.
Sums. I need to do this before dictionary.com and int. Okay, then that will create a dictionary with the integer by default. Okay, and then I just need to do this depth root. What should I pass with the level? And then sums. At the beginning, what's the level?
The level is.
What's the level of the root?
0.
Yeah, put a 0 here. So you will recursively call this. If you root is none, then just return. Otherwise, I would add the level. Look, the first time the dictionary is empty, Eric. Look, the dictionary is empty, and then by default, because we are using this default dictionary int, it means that by default, if the key is not existent in the dictionary, the value will be 0. If you're not using the default dictionary, if you're using this simple curly brace, what happens? Because there are no items in the dictionary, if you reference it, it will be a problem because there's no such item in the dictionary. That's why we use the default dictionary. There's a small difference, okay? With the default dictionary, we specify the type. It means that if the key is not existent in the dictionary, by default, we mean it's 0. So at the beginning, the sums of the level 0 is 0, and plus equal root of value, right? Then you will accumulate. Right? And then recursively, you go to the left tree with the level plus 1, and go to the right tree with the level plus 1. And Eric, the depth first search, actually, because here we are traversing the binary tree in ON, right? What's the time complexity, by the way?
ON.
ON. Yeah. What's N?
The number of nodes.
Yeah. In the binary tree, yes.
Yeah. Same as yesterday.
Yeah. Okay, so look, Eric, one question.
Yeah.
So does the order matter here? Does the order matter here? Don't shake.
Maybe or maybe not.
Does the order matter here? If we visiting the tree, alright, is it okay if I visit the right tree first? Or does it have to be the left tree?
Maybe or maybe not.
Look, the task here is we are traversing the tree, and then we update the nodes, update the dictionary with the correct sum, yeah? So does it matter if I do this first? Eric, is it okay if I do this first? For example, these 3, right? Look, Eric, 1, 2, 3. These 3 lines. Does it have to follow this order? Or can it be any order? Yes or no? Yes or no? Does it have to be this order? Can I be 1, 3, 2, or 2, 1, 3, or 2, 3, 1? There are 6 permutations, right? Yeah? There are 3 elements, 6 permutations, alright? So does it have to be this way? If I swap 2 and 3, what happens? I visit the right tree first, and then visit the left tree, yeah? And then, does it still work? Yeah? Yeah, but it still works. Be confident, it still works. It's just the way different. The purpose of this function, recursive function, is to update. The most important thing is this one, right? It doesn't matter when you do it, you will do it. It will be executed. This line of code will be executed anyway, right? So it's like adding the root of value to the sum, right? It's like a notebook.
Yeah.
Key with level and value is the sum. Okay, does it make sense?
Yeah.
Okay, after this, look, after this we have these sums which has the key which is the level with the different value. And how are we getting the maximum level for that key? Do you remember yesterday? I erased all this. Yeah, Eric? Look. Okay, Eric, sums. Like, Eric, it will be something like that. Okay, a dictionary, okay? Let's say level 0 with sum 30. Level 1 with the sum 40. And level 2 with the sum 10. So, I want to return level 1 because level 1 has the largest sum, 30, right? 0, 1, 2 is the key. 30, 40, 10 is the value. Sums is the dictionary, key value pair, which is the notebook, right?
Yeah.
Yeah. Okay, so how do we return this one? Remember yesterday? There are two ways. One way is that you can do this max, you can get this. Alright.
Return max.
This is the values, yeah? When you do this sums dot values, what does it what does it mean? Sums dot value.
Means
You will turn this into a list which is what? 30, 40, 10, right? Yeah? Does it make sense? And how about sum dot keys? Can you tell me what does it return? What are keys? Huh?
The keys are 0, 1, 2.
Well done. Okay, so look, sum dot value is this. And then if I do the max of this, so what does it mean? It will give me 40, right? Yes? And then I can for the key in sums, then if the sums key equals this 40, then I return the key, right? This is one way of doing. But another way, more easy is what? Max, you do this. Max, yeah? Look, you can't do this max sum, because what happens max sum? You will return the maximum of the keys. This is by default, right? Which is 2, which is not what we want. We want the number 1, right? Because number 1 has the largest value, right? And if you do the max sum of values, you will return 40. But I want to return 1, right? Right? Does it make sense?
Yeah.
So how do we do this? We can do this. Max sums dot items. What's items? Items, then it will be this value pair, yeah? And then look, key. I want to use a key function to determine which is the max. Key equals lambda. Okay, what's lambda mean? What's lambda mean in English?
Lambda.
What does it mean in English?
We don't know.
You don't know. I don't know either. Okay, x.
You don't know.
I want to use the x item, right? Which is x1, which is the value, right? And after that, you will give me, look, sum the item, you will give me this, yeah? 140, yeah?
Yeah.
And then I just want the key, then I do this 0, which is the key. If the 1 is the 40, am I right?
Yeah.
Does it make sense?
Yeah.
So after this, we can compute the maximum level, which has the largest sum. Does it make sense?
Yeah.
Okay, so can you tell me if I put a 1, what you will return?
It'll return.
What?
Return. What?
What? It's 0, you will return 1, and 1 you will return what? What?
It'll return.
What? What's 0 is 1 and 1 is what?
And one. Return what?
Sorry?
It will return what?
Come on, this summed item is this one. You will return because I specify the key, which is the value. I want to get the largest value, which is sorted by this 40. Yeah.
Yeah.
So this whole thing is 140. It's a tuple 140 item. So if the 0 is 1, and how about if I put a 1? What does it return? Come on, there are two numbers here.
Return 1.
Where's the 1?
40.
40, well done. Come on. See, I just said 0 is return 1, and then 1 will be return 40. Okay, does it make sense?
Yeah.
Okay, you're not paying attention. What's the time complexity?
IN.
What's the space complexity?
IN.
Why is O for space complexity?
Dictionary.
Well done. Dictionary. And also, we are using the recursion. Yeah, recursion normally has a stack. You know, if we are doing recursion, it means that usually there will be a stack involved. Yeah. Yeah, does it make sense?
Yes.
Okay, so that's it for today. Good job today.
15 minutes.
Okay, so can you say bye bye to people?
Bye.
I see you tomorrow.
Bye.
Okay, let's